Hi guys, today we're going to take a look at question 1 of paper 2 of the 2016 exam. Okay, so we have 3 points A, 6 minus 2, B, 5, 3, and C, minus 3, 4, as shown on the diagram. And we want to find the equation of the line through B, which is perpendicular to AC. Okay, so let's work through this question bit by bit. Okay, so we have our points A, which is 6 minus 2, B, 5, 3, and C, minus 3, 4, which we can see on the diagram. Okay, and so we want to find the equation of the line. Okay, so straight away, equation of the line, we're going to be looking at y equals mx plus c, or ax plus by plus c equals 0. And then the formula to get the equation of the line, we'll just include that as well. Y minus y1 equals m times x minus x1. Okay, so, and then we want, so the equation of the line is through B, perpendicular to C. Okay, so perpendicular. What is perpendicular? Well, so we're talking about a line that's perpendicular to another line, and whenever you hear that, the first thing you should think of is product of slopes equals -1. So the slope of the line we're looking for and the slope of AC, the product of those is -1. Alright, so here's the question laid out, the relevant formulas, relevant definitions, and now let's work through this. Okay, so we're looking for the equation of the line. So we look at our equation of the line formula. Y minus y1 equals mx minus x1. Well, what do we need? We need, to get the equation of the line, we need the slope plus a point on the line. So our slope, m, and a point on the line, x1, y1. Okay, so the line goes through B. Line goes through B. So we could say that B is on the line. And now let's draw this just to make it easier to conceptualize. So we're looking for a point through a line through B perpendicular to AC. So something like this, where we've got two right angles here, and we go through B. Okay, so our x1, y1 is then 5, 3. Our point on the line is B, which is 5, 3. And now we want the slope. Okay, so we want the slope. And so, well, how do we get the slope? Well, we could use the slope formula, which is y2 minus y1 over x2 minus x1. And for this, we need 2 points on the line. But we don't have 2 points on the line, okay? So maybe this is not going to work so well. But what we do know is that the product of this slope with the slope of AC, So let's call this our m. This is not going to work. So the product of our slope with the slope of AC, let's call this MAC, is -1 because they're perpendicular. Okay, and now, well, to solve for M, we'd need to know the slope of AC. And this we can solve using our slope formula, because we do have 2 points on the line AC. We have A and we have C. Okay, so point 1 is A, so A equals 6 minus 2, and we'll let that be x1, y1. And C equals -3, 4. We'll let that be x2, y2. And now we're going to put that into our formula. So y2, 4, minus y1, minus 2, all over x2 minus x1. So x2 is -3 minus x1, 6. And this gives us 6 over -9, which is -2 over 3. Okay, so the slope of AC is -2 over 3, which makes sense. It looks like it would be about that. Okay, and now we know that our slope that we're looking for times this slope is -1. And now if we divide by -2 over 3, then we'll be left with m. So m equals -1 over -2 over 3, which is just 3 over 2. Okay, so now we have our slope, and we have a point on the line that we're looking for. And so now we can use our equation of a line formula that we've highlighted in yellow here. So y minus y1, y1 is 3, so we'll call this x1, y1. So y1 is 3, y minus 3 equals m, 3 over 2, times x minus x1, x minus 5. Okay, and then if we just bring this 3 over, y equals 3 over 2x minus 15 over 2 plus 3, which is the same as y equals 3 over 2x plus minus 15 over 2 plus 3 is minus 9 over 2. Okay, so this is our equation of the line that we're looking for. Okay, now on to part B. Use your answer to part A. So use our answer to part A to find the coordinates of the orthocenter of the triangle. Okay, so let's work through this bit by bit. So we're looking for the orthocenter. Well, what is the orthocenter? So the orthocenter of a triangle is the point or the intersection of the altitudes. The intersection of the altitudes of the triangle. Well, that raises a question. Well, what the hell are the altitudes? The altitudes are, well, they're actually exactly what we just did in the previous question. So they're the lines, oops. They're these lines that run perpendicular to one side through the other point. So another altitude, well, it would be perpendicular to BC through A. So maybe it's something like, so if we extend this point outwards, it might be something like this. Something like this. So the altitudes are the lines through one point of the triangle. So in the case of part A, through B, through one point of a triangle, perpendicular to the line through the other 2 points. So in this case, perpendicular to the line AC. Perpendicular to the, through the other 2 points. Okay, so we're looking for the intersection of 2 lines, okay? Or the intersection of 3 lines, but because they all intersect at the same point, we just need 2 of the altitudes. Okay, so we already have one. So altitude 1, well, it's the equation that we just found. It's a line that we just found. So it's y equals 3 over 2x minus 9 over 2. So that's one altitude, and now we need one other. And so how might we find another? Well, we can actually just repeat the same process that we did for question 1, and we'll just switch. So instead of looking for the equation, of the line through B, we'll just look for the equation of the line through A, which is perpendicular to, instead of AC, it'll be perpendicular to the line through the other 2 points. So the other 2 points will be BC. So now we're looking for the equation of the line through A, which is perpendicular to BC. All right, and now, again, same process. We have a point on the line, so we have our line formula like we did in part A. And then we know we need to find a point. We need a point on this, which is just A equals 6 minus 2. And we need the slope. And, well, we know we don't have the slope. It'll be the same thing as last time. But we can find it using our slope multiplied by the slope of BC equals minus 1. Because, again, it's perpendicular to BC. Okay, so now we need to find the slope. So if we use our slope formula, we can find the slope of BC. So we'll have y2 minus y1 equals x2 minus x1, where, well, let's say B is x1, y1, and B is 5, 3, and c is x2, y2. So we'll say c is it 3 minus 3, 4. Okay, so now we can find the slope of BC. So MBC equals y2 minus y1, so 4 minus 3 all over x2 minus x1, so minus 3 minus 5. So this is just minus 1 over 8. And now we can use this to find the slope that we're looking for. So m times this slope, minus 1 over 8, is the slope equals minus 1. And then if we just divide by minus 1/8, m equals minus 1 over minus 1/8, we'll get the slope we're looking for, which is 8. Okay, and now we can find this, we can find the equation of the line y minus y1, which is minus 2, equals m, which is 8, times x minus x1, which is 6. So y equals 8x minus 48 minus 2. 8x minus 50. So that's our second altitude.